Welcome to our presentation on sustainability paradoxes for product modularity for the case of smartphones. In this presentation, we will quickly introduce modularity, talk about the background of circular design, and introduce our methods and case study results to then discuss these results with you. So for modular product architectures, we can basically distinguish product architectures as the basic blueprints of a product. In recent years, modularity is used for sustainability in the downstream. So really the idea is to enable product lifetime extension and recyclability through designing a product for change in use time, such as repair or upgrades and recyclability at the end of the use time. This is the modularity type we are going to talk in the next few minutes. We need to rethink product design, and in the circular product design approach, different from eco-design, the goal is really to have it as a strategic approach to also capitalize on this product longevity. And for vertical integration of these circular activities, it really creates incentives for the OEMs to have these new designs. For the smartphone industry, various modular approaches exist. Shishke et al., they identified 9 of them, and we mapped them on 2 scales here, first from visible to non-visible modularity, and then according to their sustainability aspiration. So on the bottom left, we see these types of add-on modularity and mix and match modularity that really aim at mass customization and not so much for sustainability. Probably what you think of from a modular smartphone is the Fairphone. This would be the top left corner with upgrade modularity and do-it-yourself modularity that is really visible and can be repaired by the user. But also there is internal modularity for professional serviceability that uses internal modules and that can only be opened by professionals, and there would be a monopolistic approach for circularity. And on the bottom right, we see internal modularity, which would basically be one of the older approaches that we use modularity to optimize production costs and not for sustainability. So there's not an automatic contribution of modular design to sustainability, and also various models exist and approaches. And it's important to note maybe that there's also an environmental overhead for modularity, and Fairphone showed this quite nice in their LCAs, that the connectors and additional PCB area produces more carbon footprint. And we really need a case-by-case evaluation and a good design to decrease this overhead. Also modularity could stimulate additional demand for maybe up-to-date modules. So it's not that easy, and modularity leads to sustainability tensions and trade-offs and maybe paradoxical outcomes that we want to talk about in our study. And we researched this for how smartphone OEMs deal with sustainability tensions and trade-offs when implementing modular product designs with a case study. We used a research framework that we have built based on paradox theory.
The study sites include SmartMod's headquarters in Germany, as well as its assembly sites and 2 suppliers in China. The qualitative data collection is completed through semi-structured interviews. So Ferdinand conducted the interviews at the company's headquarters in Germany, and Ferdinand and I spent a week in China to visit the company's final assembly sites and 2 suppliers. I'd like to share some context about SmartMod. It's a small-scale original equipment manufacturer headquartered in Germany. Specifically, the design and repair team is based in Germany, and the proprietary assembly line is based in China. SmartMod designs its own assembly line to be flexible for its workers and operators. Its assembly operators are trained and able to complete any tasks at the assembly line. The operators have flexibilities to work and work on different tasks, and they can discuss their preferences with their manager. The trade-off specifically based on the modular product design. And this is based on our observations on the ground. And we divide these findings based on life cycle phases of the product in the design, production, and use phase. And for today, I'll highlight two of the trade-offs with you next. The first one is the trade-off between modular design and durability. While modular product manufacturers intend to produce products that are easier to repair and upgrade, their products might require additional mechanical connections. These connections could cause higher failure rate of the modules and incur higher environmental cost. The trade-off solution is a concept of two-level modularity invented by the designers at SmartMod. The idea is that the product prioritizes modules that are easier to be broken and require repair to be modular, while keeping an integrated design for parts that are keeping the structural integrity and improve the product reliability of the product. So on a system level, the paradox that we acknowledge is that while modularity could enable repairability and circularity of the product, it may decrease the durability of the product. The next trade-off that I like to go through is the trade-off between flexibility versus efficiency during the manufacturing process of the product. The intention of the product producer is to increase the flexibility of workers and improve workers' experience, as I've shown in the photos earlier. However, the reality of the industry is that conventional assembly line is highly efficiency oriented. Operators are very specialized to conduct a single task at a long duration. The design intention by the modular product producer is to facilitate a flexible assembly line that enables workers to work flexibly and improve their work experience. The trade-off solution that SmartMod has designed is the idea of two delivery speeds, which allows some customers to purchase from the stock, while other customers purchase from the product on demand and ahead of time. This essentially requires customers to pay for a price premium for the efficiency. The system level observation is that there is tension between the pursuit of operators' flexibility and experience as opposed to the economic and cost efficiency.
Next, we want to discuss some innovations with you that we have observed. And these are the two-level modularity and the flexible assembly line that Lynn already introduced. For the two-level modularity, really the idea is to have this trade-off solution that some parts will be exchanged and others not. And of course, then some questions occur, right, Lynn?
Yeah, so how can we tell about the optimal level of modularity? How do we define that? And in addition, who is performing the repairs and upgrades and who should be responsible for this? Is this the OEM's responsibility or third party or even our users' responsibility? And lastly, which part should be replaceable? That's also an unanswered question.
So drop us a line in the comments for if you have any ideas or any comments. And also for the flexible assembly line, really a new universe for final assembly can emerge. Because there's no soldering and no gluing, it's just really putting the parts together. It enables a new work environment, as Lynn explained. And really we could think about assembly at home even. And in times of Corona, we could also have local regional assembly hubs, maybe in Germany or Europe or the United States for these phones. So also drop us a line if you have any comments about this. On a system level, these paradoxes that we explained emerge, and really they're three elements we want to discuss also with you. The first one is that modular product design evokes additional system level implications. So we have to define interfaces, we have to define standards and protocols, and really these modular products, they more interact with their system. So for example, they interact with the user and also the OEM because they require corresponding circular services like the repair to be environmental efficient. So this additional system level implications are also a point we want to discuss with you.
We also find that there are limits of a single OEM. While a single company such as SmartMod has the greatest intention to facilitate sustainability, it encounters roadblocks to improve the sustainability of the production consumption system. We observe paradoxical outcomes that are beyond individual companies' control. So all of the paradoxes could potentially lead to shorter product lifetime, which is not intended by these individual companies. So given these observations, we encourage you to join us to rethink what we could do in order to create a more sustainable production and consumption system. We outlined 4 points for you to consider and welcome your written feedback in the box below. The first idea is the idea of interfirm modularity. It's an idea that's mentioned in scholarly literature, but we haven't seen much practice yet. The idea is that companies could facilitate modules that could be exchangeable and compatible with each other. The reality that we've seen are still companies, individual companies, they're not really compatible to other companies' modules. The second point is an ecosystem-based approach in that in the hardware space currently, as mentioned before, the individual companies' products are not necessarily compatible. While if we look at other space, for example, the software space, there is the application ecosystem where companies can follow similar standards and coordinate and have a facilitator to coordinate an individual's action. So that might be a possible approach. The third point to think about is, are there policy instruments or incentives that could encourage OEMs or individual companies to be more proactive in trying to pursue a more sustainable production consumption relationship? The last one is to continue thinking through how modular product design could help achieve new EU requirements, specifically in repairability and product durability. So with that, I'd like to conclude the presentation and thank you very much for joining us today. We're excited to hear your feedback.
Yes, thank you very much. You can write in the box below or write to us individually, and we are happy to respond. Bye.